Hi and hello everyone. Welcome to the 6th episode of Math Time. In this week's lesson, we're going to start going over 3D figures. The main ideas of this video are what 3D figures are and how we can classify them, what a net is, and then how we can use that net to find the surface area of a 3D figure. A polyhedron is the three-dimensional extension of a polygon. Much like a polygon had to have straight sides, a polyhedron has to have flat polygon surfaces connected by straight edges. As you can see, each one of these dice is a polyhedron. Just like with polygons, no curves are allowed. So circles and semicircles are not polygons, so this hockey puck and this baseball are not polyhedrons. There are two main types of polyhedra we want to be able to consider. The first are prisms. A prism has two congruent polygon bases, and those bases are connected by parallelograms, usually rectangles. The base of the prism can be any polygon as long as both bases are congruent, the exact same shape and the exact same size. A pyramid has a polygon base and triangular faces that meet at a point. Just like with a prism, a polygon can be any figure as long as the faces are triangular and they all meet at one point. These polyhedra are named by whatever figure the base is, followed by the word pyramid or prism. So for example, a prism with pentagons as a base will be a pentagonal prism. A pyramid that has a square base is a square pyramid. A net is a 2D representation of a three-dimensional figure. Think about the figure being unfolded. We should also be able to identify what kind of polyhedra we are looking at by its net. I can tell that this net represents a prism because it has two congruent polygons and then a handful of rectangles there that would connect them together if I were to fold it up into its 3D shape. And the congruent bases are hexagons. That makes this net a hexagonal prism if it were folded together. The second net, I can tell, represents a pyramid because it has one polygon as a base and then a handful of triangles that if I folded them together would all meet up at the top. So this is a pyramid. The figure at the bottom is a pentagon, which makes it a pentagonal pyramid. Finally, this third net is a special net. This one is a cube or a square prism. The two congruent bases would be squares, and then the other squares connecting them turn this into a square prism, or better known as a cube. Nets are going to come really in handy when it comes to finding the surface area of a figure. The surface area is how much area is added up among all of its faces. Think how much paint you would need to cover a total surface. So our process is going to be unfold the shape into its net, find the area of each face of the net, and then add up all of those areas. So for this first example, we have a pentagonal prism that I want to find the area of. So we're going to unfold it into its net, and we should see that we have two pentagons and 5 rectangles. For each of those rectangles, we're just going to use area equals base times height. And then for the pentagons, we're going to use the same formula we used last week. The area of a regular polygon is 1/2 times the perimeter times the apothem. So our rectangles are 6 units by 6 units, so the area for those is 36 square feet. For our pentagon, the perimeter is 30. There's 5 sides, each are 6 feet long. The apothem is 4.1 feet. So that means the area of our pentagon is 1/2 times 30 times 4.1, which is 61.5 square feet. Now to get the total surface area, all we got to do is add up all of the areas. 36 plus 36 plus 36 plus 36 plus 36 plus 61.5 plus 61.5. And that will give us our total surface area of 303 square feet. I'm going to repeat the process for this second example. This one is a pentagonal pyramid. So that means I have 5 triangles I need to find the area of, which is 1/2 base times height. And then I have the pentagon at the base I need to find the area of, which again is 1/2 times the perimeter times the apothem. The base of the triangle is 12 meters, and they are 13.8 meters tall. So that means the area is 1/2 times 13.8 times 12, which is 82.8 square meters. The area of the pentagon is 1/2 times the perimeter times the apothem. Each side is 12 meters long, so the perimeter is 60 meters, and the apothem is 8.3 meters. So our area is 1/2 times 60 times 8.3, which will give us an area of 249 square meters. So that means the total surface area for this pentagonal pyramid is 82.8 plus 82.8 plus 82.8 plus 82.8 plus 82.8 plus 249 for a total area of 663 square meters. So just to recap everything, we defined what a polyhedron is and gave a few definitions for the specific polyhedron we want to be able to work with. I defined what a net is, and we used those nets to identify some, and we used those nets to classify some polyhedra. And then we used those nets to find the total surface area of a prism and a pyramid. Stay safe, stay healthy. It's a great day to be a Buffalo.